Good afternoon, students. I am going to teach you hybridization. Okay, hybridization. How we come to know about hybridization? Just take an example of a carbon. Okay, how does it work? So, carbon atomic number is a 6. Okay, so when we change it into sp-df orbital, it will be in a first orbital there will be 2 electron. Okay, and as we know that electron, when we fill electron, it will be in a opposite spin, not in a same spin. So 1 s2, there is a 2 electron in a same orbital, that is in a different, like spins are change here. Okay, and 2s2, there is also 2 electron where spin is a opposite, it is change. And in a third orbital there is a only 2 electron, but the third one is a vacant. Okay, so that's why here we can count the orbitals here: 1s2, 2s2 and 2p2. Is it clear? So now come how we understand the hybridization topic. Number of half-filled orbital present in the outermost shell of its atom. Which atom? Carbon atom. According to the ground state electronic configuration of carbon is, it should be divalent. Okay, according to ground state electronic configuration of a carbon, it should be divalent. Okay, plus 2 electron will be there, but actually it is a tetra covalent in most of its compound. Okay, that's why we can write it like a anion. And also C4 plus is a cation. Okay, why I'm going to explain you, because it can lose it a 4 electron to complete its octet, and also it can donate its 4 electron to come in a inert gas configuration. Okay, and what is the rule of hybridization? Rule: similar energy orbital take part in a hybridization. Similar energy orbital, not a different types of energy will be present in a part of a, will take a part in a hybridization. Okay, second is a hybrid orbital is equal to atomic orbitals. Okay, so hybrid orbitals are equal to atomic orbitals. And third is hybrid orbitals form only sigma bond, and a hybrid orbital are only can form sigma bond, not a pi bond. Okay, and fourth is they are not identical in a shape, their shapes are not identical. Okay, so this is all the rules of hybridization. I just show you by one example, which is a carbon. Okay, so there are more example. Okay, but in this class I just show you only one example. Okay, and just see what things affect hybridization. Okay, so bond angles. Okay, bond angles are greater in a sp, where s characters are more and p characters are s character increasing and p character decreasing. So there bond angles will also increase. In sp orbital we can see that 180 degree. Okay, in sp2 there is a 120 degree, and in sp3 there is a 109.5 degree. Okay, so bond angle depend on a s and p character. When s character increases, p character decreases, so sp value are greater there. Okay, so we can see in this there also. And bond length increases when size, it depend on size of orbital is indirectly proportional to s character. Okay, so where s character are higher and p character are s character are higher, so it bond lengths are lesser, and p character are higher, so bond lengths are also higher, because it is a size of orbital are indirectly proportional to S character. When S character increases, bond length decreases, and if S character decreases, bond length will increases. So we can see that sp3 bond length are greater than sp2, sp2 bond lengths are greater than sp. Okay, bond length are indirectly proportional to percentage of S character. Okay, and third is a bond strength, energy. Okay, so bond strength are also indirectly proportional to bond length. Okay, so bond length, when bond strength are indirectly proportional to bond length. Okay, so here sp, sp2 and sp3. So sp, here s again S character are increases and p character are decreases. So sp has a greater bond strength than sp2, and sp3 has a sp2 has a greater bond strength than sp2. So it depend on bond strength or depend upon bond length. Bond length is directly proportional to bond strength. Bond strength is directly proportional to percentage of S character. Okay, fourth is electronegativity. Electronegativity is also dependent upon sp characters. So here is also sp or sp, s increases, p decreases. So this is electronegativity. sp are more electronegative than sp2, sp2 are more electronegative than sp3. Acidity, acidity is also increases for saturated hydrocarbon, that is a alkane. It's a increases for alkane, then alkene, and alkane, alkyne, and alkyne acidity is lesser than alkene. Okay, so acidity is much more in alkane than alkene, and in alkene that is more than alkyne. Okay, I hope you all understand this class. In the next class I will bring how to prepare saturated hydrocarbon, that is alkane. Okay, until then, goodbye.